I'm going to start with a quick timeline. We're not starting at Plymouth Rock. We're actually more recent. I don't want to reveal my age, so I'm going to start in 2000s. So let's go through history. History is about to repeat itself. If we look in the past, in early 2000s, we had tier 1 OEMs that were providing servers for the current data centers for dot-com bubble that we all know where it went. And we had companies that were very innovative, like Rackable Systems, one of the first white box guys that I had a pleasure to work with, that established white box and started adopting it. And all the major cloud companies started adopting it. Then we had a Dell DCS come online and customize their own hardware and kind of competed with Rackable. And then comes my story, Hive Solutions. I was fortunate to establish and work in that company and be one of the founders. Now, in that time period, it was kind of hard to do business. And things have changed, and history had changed. So out of Hive Solutions, my first customer I decided to cut my teeth on was a small guy never heard of called Facebook. And you can actually see me signing a first rack being delivered to Oregon Data Center as their first deployment, their first new data center. Now, there are several things that have changed, and we can see hardware how it migrates to where we are today. First, you start with disaggregation of the server. Then you move on to disaggregation of storage. And you can see Knox there being in storage. Then you disaggregate the rack and power. So you have an open rack with bus bars and so on and power shelf. Then you disaggregate networking. You have bare metal switches. And that time you'll see Microsoft joining in OCP and also at the same time contributing to all of their design. That changed the world. That changed how people think about hardware. That became a lot more sexy, and companies started adopting it broadly. So there's no longer just a tier 1 in that market. Then comes to 2016, and that sketch you see, this is actually what Yuval drew on his blackboard. So history repeats itself. A year later, we are here at Open 19, and I'm happy to present Open 19 servers in a rack. There actually will be live later today. So with that, I'd like to hand over the clicker to my friend and colleague, Dharmesh Jani. He is VP of Cloud Labs, and he will walk you through what things are driving today's technology and data center.
Thank you, Adam. Good morning, everyone, and it's great to see all of you here. And also a very warm welcome to many more who are tuning in live through Facebook feed. So we are all aware over the last many years on the growth of the traffic which has happened over the network. In fact, most of us as consumers have contributed to this growth by demanding more video services such as the one which is happening right now, by demanding that we have our homes upgraded to smart homes with all the IoT devices in there, by demanding that we have intelligent assistants at home which answers every one of our questions. And tomorrow, we are going to demand more as new services based on immersive reality becomes available. As a result of this insatiable demand, somewhere between 2016 to present day, we have entered the age of zettabyte era. Today, the annualized traffic running through the network exceeds 1 zettabyte. Just to put that in perspective, that's as much traffic as downloading the entire Netflix catalog 3 million times over. Or, an analogy which I like to refer to, you have a cup of coffee, which many of you are drinking today. If you assume that as 1 gigabyte, 1 zettabyte is enough volume to fill the entire Great Wall of China. This traffic demand is going to even grow further by the time we reach 2020, and some projections say it's going to grow 7x. As we look at these new workloads emerging, they are going to demand new performance both on bandwidth and latency. And they are spread all over the map. You have sensors on IoT, which are going to chirp, tweet at very low thresholds on one extreme. On the other extreme, you would have AR, VR, real-time videos, which will demand not only very high bandwidth, but extremely low latency to ensure that you have a quality experience. You can look at it in a broad 4 buckets, which kind of divides these new emerging workloads. You have videos and things which will run perhaps on relatively high latency network, but demanding bandwidth requirements between low and high. On the other extreme, you will have AR, VR, and system control protocols, which will demand ultra-low latency, even if they might run on different bandwidth. Today, if you look at any of the services which are running in your home, on your smartwatches, on your laptops, on your smartphones, they are all running on the back end through a centralized cloud, which is connected via a network spanning core to edge. But you have latency which is related to the distance you are from this particular centralized cloud. The further you are away from this cloud physically, the longer it will take for you to get the response. And I just mentioned on the previous slide that different workloads are going to require different latency requirements. So they will be physically distributed across network. You cannot have all of these running in your centralized cloud because your latency needs will not be met by all of them. And in fact, you heard from the previous presentation, Cole mentioned somewhat similar concepts. So today we need distributed cloud, which is emerging. All of these workloads are going to be physically distributed across set of different clouds, all of different sizes. At the core, you could have hundreds of racks running and serving your queries or whatever workloads which require high latency and high compute. But you might be running some workloads in a central office, somewhere in the middle of a city, and they might demand lower latency. And in some cases, you might even be running workloads right near remote radio heads or at base stations if you want ultra-low latency. So distributed cloud is something which is the only way we can address these demands from these new emerging applications. There's no other way. Again, speed of light, I would say sticks, rather than, what Cole was saying. So network clouds to the intelligent edge is what we need to make all of this happen. So how are we going to go about putting these kind of distributed clouds? We need a composable architecture which can be deployed in a brownfield environment as well as in a greenfield environment, and which can deliver cloud services, microservices, which can provide time to market for service providers and others by having software and hardware integration at a much faster rate than possible. And at the same time, it also ensures that the disaggregation is done at the right level where it still fosters innovation. And you heard that earlier through the morning, everyone talk about how the disaggregation limit has to be chosen perfectly to make sure that each vendor and each supplier can still innovate. We believe Open19 with its open shelf, self-contained server bricks of different form factor, self-contained power shelf, embedded switch, connectorized data plane and power plane connectivity provides such an architecture which can make distributed clouds possible. Today at Flex, we are involved in designing or providing all of these components which go into Open 19. Mechanicals, compute servers, storage servers, embedded switch, power shelf, and in fact, we are even integrating these at entire rack scale to provide a solution for such emerging needs. And you can see more about it later at our booth. Beyond looking at the hardware itself, we are also looking at ways to integrate software stacks which are available using our homegrown automation tool, which are based on open source ecosystem. Open 19, as you know, is a rack scale design, and we are integrating number of technologies into this rack scale design, which ensures that we can do system monitoring, we can look at power efficiency, working with something like Vapor IO OpenDCRE or Intel DCIM, using Redfish and OpenBMC, and by integrating RESTful API commands in our BIOS and BMC. This is something which most customers are looking for in terms of having diversity of health monitoring systems. Beyond that, we are looking at server software platforms. We are characterizing our bricks to ensure that they are certified on all of the available server storage platforms. And then we are looking at all the emerging cloud platforms which can be used for orchestrating or deploying clouds as needed. You can have a small instance of a cloud for a location which is physically small, and in some cases you can have a large instance of cloud. And then beyond that, it's all about providing services. And these are the stacks which we are working to automate using a very popular configuration management tool. In fact, it's one of the #1 on GitHub, which is Ansible, which we use as a configuration management tool. And we work with Stacky, which is our system imaging tool, to rapidly image a rack or multiple racks. And then we can look at open source workload benchmarks, such as Google PerfKit or Yahoo Cloud Serving benchmark, or even something like IXIA, to look at how the entire solution is performing. We capture all of these through Grafana for visualization, so that you can do the performance optimization in an iterative fashion. And then we use Telegraph, which is an open source tool for health monitoring. As a matter of fact, later on during the lightning talks, we will show a live demo of a microservice instance which is running a Redis database on Open 19 system. So you can see that we are deeply engaged with the Open 19 architecture, and we are extremely excited to be part of this fantastic opportunity where the industry can move to provide the new services which we all as consumers are going to benefit at the end of the day, and our kids are going to benefit at the end of the day. So with that, I will hand it back to Adam. Thank you, Adam.
Thanks, DJ. So you all know you're at Flex facility, so I'm going to have to bore you with a few slides about us. And hopefully this is a lot of good information for you to really understand who we are and what we do. So why work with Flex? Not because we have 200,000 employees, not because we have $25 billion in revenue, not because we have 2,500 design engineers, but because we participate in all markets. As you can see, we have substantial spend in each market, and we have unique view in this industry that no one else has. And all of these industries actually are driving cloud in a very unique way. We are able to connect the dots and offer that to all of our customers. Specifically that each industry, it could be a little bit different, even though they all could adopt Open 19, but could be maybe different form factor, different workload, and so on. We have over 100 locations globally in 30+ countries. Now, this is just a short snapshot of where the integration locations and design locations are. Now, if you look real closely and overlay the current mega-scale data center locations, you'll see they mimic the locations pretty close. So we're in very close proximity to the largest data center deployments for cloud. So why Flex? Why now? Well, this is a really great question. Come in with your own napkin, draw something on it. We can design it together. We can design ourselves for you. We can take your current design and modify it and optimize it, or we can take your current design and manufacture it. We can take this globally because we have global footprints, and we can replicate it in countries that are really hard to get into. We call this sketch to scale, and this is what we're all about. Thank you very much.